Hi guys, Ankit here and let's just talk about states of matter. You would probably know about the three classical states of matter, that is solid, liquid and gas. And if you were a real science geek, you would know about plasma and Bose-Einstein condensate. But still that's not enough. There are minimum 15 states of matter. I mean, there are just so many, you can write a whole book only on the topic states of matter. Now our first state of matter is fermionic condensate. Now this state is very much related to Bose-Einstein condensate as they both need the same temperature, that is approx 0 Kelvin or say minus 273 degrees Celsius, and they both act as a single atom. But the basic difference comes at their building blocks, that is Bose-Einstein condensate are made up of bosons while fermionic condensate are made up of fermions. Now what's the difference between fermions and bosons? You can simply differentiate it with the help of Pauli exclusion principle. That is, fermions follow Pauli exclusion principle while bosons doesn't. I have given a link down below that will help you know what is Pauli exclusion principle. Now it's okay, we find a new state of matter, but if it doesn't have any application, means it's a waste. But actually it doesn't. Fermionic condensate act as a superfluid, means if you drop a drop of a fermionic condensate on the floor, it will flow till infinity because it doesn't lose any energy. That's why it can be used as power generators and supercapacitors. Now the another state of matter is little bit confusing because it has the property of liquid and at the same time has the property of gas, but it is neither a liquid nor gas. It is something between them and we call it supercritical fluid. Just imagine, take a glass of water and you will observe a fine line that will divide the liquid state from the gaseous state, that is air. And we seal the glass and now we'll try to erase that line with the help of increasing temperature and pressure. And after some time, the line vanishes, we will end up with a new state of matter, that is supercritical fluid. And the temperature and pressure responsible for new state of matter, we call it critical temperature and critical pressure. I've given a YouTube link down below of the channel Nottingham Science, as those guys have demonstrated the creation of supercritical fluid. Now the application of this new state of matter is very limited for today, as it is generally used in laboratories for many processes like atomization, crystallization, enrichment, and etc. etc. And for industrial purposes, it is only used for decaffeination. Now moving on, do you remember the lightsaber from Star Wars? No, I'm not moving out of the topic, I'm just saying that it's not a fiction, it's reality. And the matter that causes this reality, we call it photonic matter. It is a neutral matter that are made up of binded photons. It is different from the scattered photons that is emitted when you switch on the torch or your light bulb. Actually, what happened when scientists created a vacuum chamber and pumped gaseous rubidium ions in it and then cooled it down with the help of lasers and firing photons. After some time, the photons loses its speed and were forced to bind it together. And this created a whole new state of matter that we call photonic matter. Now the state of matter that I am talking about is very much interesting for me because just imagine, take a material that is originally an insulator and then apply a little bit of pressure on it and it's become a conductor. Not only a conductor, a superconductor. The superconductor concept is same as superfluid, that it conducts without losing any energy or say without any resistance. And then apply a little bit of more pressure on it and it's become magnetic. This what happened at Japan when Japanese scientists were trying to dope C60, that we generally call bulky balls, with rubidium atoms. That causes a wonderful effect that we call John Taylor effect. And that's why the matter is called John Taylor metal. Actually what happened, when we apply a little bit of pressure on it, it changes its construction and ultimately changes its properties. That's why originally it was an insulator, but applying a little bit of pressure on it, it changes into conductor. And applying a little bit of more pressure on it, it changes into magnetic. Now you can just think the possibilities that can produce this matter. Now I know the video is going too long and still I have to cover many interesting states of matter including time crystals, degenerate matter, glucon plasma, but time is limited. So thanks for watching.